In this example, we're dividing using the division algorithm. And I'll show you how. I don't think this one has a remainder, but the reason we are using the division algorithm is because there's a binomial in the denominator of the fraction. So we're going to use long division on this. First thing we need to do is add zeros in for any terms that are missing. So what that means is in the numerator, we had a y third and we had a y. We didn't have any y squared in between, so we have to add that in because we need descending powers in the numerator. The denominator's fine as it is, but here's what the descending powers need to look like in the numerator. If you have a 3, you have to have a 2, a 1, and a nothing or a 0 in order to have all of your descending powers there. We have to add this in because if we didn't, it would be difficult to do the long division. Now we're going to write the long division expression. The y minus 2 goes outside the box, and the new numerator with our 0 is going to go underneath the box or in the house. The next thing we're going to do is take a look at just the first term in the divisor and the first term in the dividend. So y and y third, that's all we're looking at. Everything else will work itself out. What we need to know is y times what will give us the y third. And you have one y, you need two more, so it's y squared. The y squared is going to be put on the top, right over the place where you looked, right over the place that you looked at. And then we're going to take that y squared and the y minus 2, and we need to distribute that. We actually have to multiply those two things together. So we're going to multiply those. That gives you y to the third minus 2y squared. And we're going to end up subtracting that expression. So I need to distribute a negative, and that gives me negative y third plus 2y squared. This is what I'm going to write back into my long division algorithm. And I'm going to write it directly underneath where I'm lining up my y's to the third power, and I'm also lining up my y's to the second power. And this is why we added the 0 y squared, because we needed those to line up. So that will eliminate the y to the third, which is what we wanted, and then we can just add together the 0 and the 2 to get 2y squared. Let's bring that 3y down, and now we're going to do that whole process again. We're going to look at the y, and this time we're going to ask ourselves, y times what equals 2y squared? Well, we need a 2 and a y. So y times 2y will give you the 2y squared. And that's positive, so we're going to put a plus 2y at the top in our quotient area. And then we're going to take the 2y over to the side and distribute that with the y minus 2. So go ahead and distribute, and that gives you 2y squared minus 4y. We will need to subtract that. So we're going to distribute a negative, and that gives us negative 2y squared plus 4y, and that's what we're going to write back into our algorithm. Notice that everything lines up, and your positive 2y squared and negative 2y squared will cancel, and we need to add the 3y and the 4y to get 7y. Next, we're going to bring the 14 down, and we're going to do the process one more time. The y goes into the 7y how many times? Y times what equals 7y, and we just need a 7. We're going to add the 7 to the top where the quotient is, and then we're going to take the 7 over to the side and distribute it with the y minus 2. That gives you 7y minus 14. We need to subtract that, and that will give us negative 7y plus 14. This is what we're writing back into the division algorithm. Everything's lining up. And in this case, because I told you at the beginning we don't have a remainder, our 7y's cancel out and our 14's cancel out, leaving us no remainder, which means the quotient that we wrote, the y squared plus 2y plus 7, is actually our final answer.